Alrighty, so in this question we're going to use the limit definition of the derivative to show that 9 minus 2x squared gets me to negative 4x when we take the derivative. And so the first thing I'm going to do is write out the limit definition of derivative, which is the limit as h approaches 0 of f of x plus h minus f of x all divided by h. And so the way I usually work this out is I'll break it up into two sections. One with f of x plus h, and the second one with f of x. And so when I start writing these out, I'm going to go ahead and plug in my numbers. We have the limit as h approaches 0 of, here we have f of x plus h, so I'm going to replace all of my x's with x plus h's. That's all that is. So we have 9 minus 2x plus h squared. All right, and then we're going to subtract from f of x, which is just our function unchanged. So 9 minus 2x squared. And then we're still going to be divided by h here, okay? And so the idea of this is that we can't go ahead and take the limit right now, because if we plug 0 in for h, we'll have something that's undefined. So what we need to do is work it out a bit and simplify it out so that hopefully we can cancel the h off the bottom. So the first thing I'm going to do that I see that we can do is I'm going to distribute the x plus h squared. So what we should have is the limit as h approaches 0 of 9 minus 2 x plus h squared should get me x squared plus 2xh plus h squared minus, and then 9 minus 2x squared turns into minus 9 plus 2x squared when I distribute that negative, all divided by h. So the next thing I could do is I could distribute that 2 out onto that very long polynomial. We should get limit as h approaches 0 of 9 minus 2x squared. And then the negative does stay on that too, so it'll turn into negative 4xh minus 2h squared minus 9 plus 2x squared. And we're all over the h still. And so from here, I can see that a couple things will go away. We have a negative 2x squared and a positive 2x squared, so those two things will cancel. We have a 9 and a negative 9, so those two things will cancel. And you'll see what we're left with is we're left with everything on the numerator. So minus 4xh minus 2h squared has an h in it. And so we can go ahead and cancel one h from each of the terms on the top to get rid of the thing on the bottom. And so what we're left with after that is that we should have the limit as h approaches 0 of minus 4x minus 2h. And so when I take the limit of that, that first term doesn't change at all because there's no h's in it, and that second term will go away when I plug in 0. And so all that's left is minus 4x, which is our answer. And we can see that that go ahead and matches with our problem statement where we proved that 9 minus 2x squared is equal to negative 4x.
So for this problem, we're asked to use the graph of f here to determine these values below. So the first thing we're going to want to do is see what we're doing. The limit as x approaches 5 from the left of f of x, so we're going to find x equals 5, which is over here, and we're going to come up to it from the left. Well, we're getting closer and closer to the y value, negative 1. So that's my solution here, is negative 1. The limit as x approaches negative 4 from the right, that's what that plus after the number means. So as we get closer and closer to negative 4, you'll see that we're going up, 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 up. So our y value is going up, 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 all the way to infinity because we're approaching an asymptote. The limit as x approaches negative 6 of f of x, well, if we look over here at negative 6, we can see that we have the point right here. And so as we come in from the left and from the right of this point, we see that it's the same, and that's at the point y equals 2. So for this next one, we're asked to do the limit as x approaches 7 of f of x minus f of 7 over x minus 7. Well, notice that this is just a slope formula. This is y2 minus y1 over x2 minus x1, essentially. So we're really just asked to find the slope here at the point x equals 7. So we're on this line, so we can just use rise over run to let us know that if we kind of look over here, we can imagine that this point is filled in. It's not, but we can use it as a reference point for the line we're currently on. And we can use it to say then that we can take the slope between those 2 points. So that would be 5 minus 3 over 7 minus 6, which would equal 2. So for f prime of 6, since we're looking at f prime, that means we're talking about the derivative. So we're trying to find the derivative at x equals 6. Well, the thing to note is that x equals 6, we are non-differentiable. And the reason we're non-differentiable is because we're not a continuous function there, and you have to be continuous to be differentiable. We have that jump there at x equals 6 from 2 to up to 3. So f prime of 6 does not exist, or d and e. So df over dx at x equals negative 5.17, that means that we're really just saying f prime of negative 5.17. So we're asking about the slope at negative 5.17. So that would be the slope somewhere like right in here, essentially. Well, same thing, we can just do another slope formula between this point and our point here at x equals negative 6, and that's going to give us that we'll have negative, or sorry, 0.5 minus 2 over negative 5 minus a negative 6. Well, that's going to just become negative 1.5 over 1, which equals negative 1.5. So that's my slope for this line segment between x equals negative 4 and x equals negative 6. So for the next one, the limit as delta x approaches 0 of f of negative 5 plus delta x minus f of negative 5 over delta x. So once again, this is just asking for slope. This is of that form y2 minus y1 over x2 minus x1, where our x2 minus x1 was of the form negative 5 plus delta x minus a negative 5, which becomes negative 5 plus delta x plus 5. So the 5's cancel out, and we're left with just delta x, which is what we have on bottom right here. So once again, this is just asking for slope at this point, so it's going to be negative 1.5 again, because we just did that in the last problem. Oh goodness, I cannot write today. So then we're asked to do f prime of 4. So f prime of 4 is just finding the slope at 4. So we're finding the slope at this point right here. So if we look at that, we can imagine drawing the tangent line and finding the slope of that. But the tangent line is just a horizontal line, which means that our slope is going to be 0, because the slope of any horizontal line is 0. And a good thing to know is that anytime you have a maximum or minimum, the slope at that point is 0. And then for lastly, we're doing the limit as x approaches negative 3 of f of x. So as x approaches negative 3, we're getting closer and closer to this point right here. So we're going to look at the values, the y value we're approaching from the left and from the right. And we'll notice that that's getting closer and closer to the value 2. That's not the value f of negative 3 because there's a jump there, but that's the limit that we approach. So for part B, we're asked to identify all x values in the interval negative 10 to 10 where f of x is defined, but f is not continuous. So that would be places where we have like vertical asymptotes or jumps. Those would be some examples of places where we're not continuous. So if we look, that would be at x equals negative 4, negative 3, 5, and 6. And now we're asked to determine which of those we are defined at. So defined just means I could plug in that x value and I would get out an actual y value. So for us, if we look at negative 4, I can't ever plug in negative 4 because it's an asymptote. So if I can never say f of negative 4 equals something, so that's not defined. But I can, looking at negative 3, plug it in. And when I do so, I would get f of 3 equals 4, so we're defined at that point. So I know that x equals negative 3 is one of my answers down here. Looking at x equals 5, notice that there's a jump there, but neither of those circles are filled in. So I can't say f of 5 equals anything, so 5's not defined. But looking at x equals 6, there's a jump, so we're discontinuous. But I can say that f of 6 equals 2, so we are defined. There is a y value, so x equals -3 and x equals 6 are the x values where I'm defined but not continuous.